The C-5 Galaxy is a heavy cargo transport designed to provide strategic airlift for deployment and supply of combat and support forces. The C-5 can carry unusually large and heavy cargo for intercontinental ranges at jet speeds. The plane can take off and land in relatively short distances and taxi on substandard surfaces during emergency operations. The C-5 and the smaller C-141B Starlifter are strategic airlift partners. Together they carry fully equipped, combat-ready troops to any area in the world on short notice and provide full field support necessary to maintain a fighting force. Using the front and rear cargo openings, the Galaxy can be loaded and offloaded at the same time. Both nose and rear doors open the full width and height of the cargo compartment, allowing drive-through loading and unloading of wheeled and tracked vehicles, and faster, easier loading of bulky equipment. A kneeling landing gear system lowers the aircraft's cargo floor to truck bed height. The entire cargo floor has a roller system for rapid handling of palletized equipment. 36 fully loaded pallets can be loaded aboard in about 90 minutes. The Galaxy's weight is distributed on its high-flotation landing gear, which has 28 wheels. The landing gear system can raise each set of wheels individually for simplified tire changes or brake maintenance. An automatic troubleshooting system constantly monitors more than 800 test points in the various subsystems of the C-5. The malfunction detection analysis and recording system uses a digital computer to identify malfunctions in replaceable units. Failure and trend information is recorded on magnetic tape for analysis. The C-5, with its massive payload capability, has opened unprecedented dimensions of strategic airlift in support of national defense. For 20 years it has been involved in many historic airlift missions and is invaluable to the Air Force mission and humanitarian efforts. For example, in December 1988, 4 C-5s participated in the delivery of more than 885,000 pounds, 398,250 kilograms, of earthquake relief supplies to the then Soviet Republic of Armenia. The C-5 also assisted with an Alaskan oil spill cleanup in March 1989, transporting nearly 2 million pounds, 900,000 kilograms, of equipment to Elmendorf Air Force Base, Alaska. The most dramatic display of the Galaxy's capability and value was during Operations Desert Shield and Desert Storm. The C-5, along with other Air Force transport aircraft, airlifted almost 500,000 passengers and more than 577,000 tons, 519,300 metric tons, of cargo. This included 15 air transportable hospitals, and more than 5,000 medical personnel to run them, and more than 211 tons, 189.9 metric tons, of mail to and from the men and women in the Middle East, each day. The C-5M Super Galaxy is a strategic transport aircraft, and is the largest aircraft in the Air Force inventory. Its primary mission is to transport cargo and personnel for the Department of Defense. The C-5M is a modernized version of the legacy C-5 designed and manufactured by Lockheed Martin. Currently the U.S. Air Force owns and operates 52 C-5BCM. They are stationed at Dover Air Force Base, Delaware, Travis AFB, California, Lackland AFB, Texas, and Westover Air Reserve Base, Massachusetts. The C-5M Super Galaxy is equipped with 5 sets of landing gear, 28 wheels, 4 General Electric CF6-80 C2L1F F138 commercial engines, and a state-of-the-art maintenance diagnostic system. It can carry oversized cargo over intercontinental ranges, and can take off and land on relatively short runways. Both the nose and aft doors open, allowing ground crews to simultaneously load and offload cargo from both ends, reducing cargo transfer times. The full-width drive on ramps at each end enable double rows of vehicles to be transported. The maintenance diagnostic system has the ability to record and analyze data from more than 7,000 test points, reducing maintenance and repair time. The C-5M, with a cargo load of 281,001 pounds, 127,460 kilograms, can fly 2,150 nautical miles, offload, and fly to a second base 500 nautical miles away from the original destination, all without aerial refueling. With aerial refueling, the aircraft's range is limited only by crew endurance. Lockheed Georgia Company delivered the first operational C-5A Galaxy to the 437th Airlift Wing, Charleston AFB, South Carolina, in June 1970. In March 1989, the last 50 C-5BS was delivered, adding to the already existing 76 C-5As in the Air Force's airlift inventory. The C-5B included more than 100 additional system modifications to improve reliability and maintainability. Additionally, in fiscal year 1989, 2 Space Cargo Modified (SCM) C-5CS were delivered. The modification included removing the troop compartment, redesigning the aft pressure door and bulkhead, and widening the aft doors, so the aircraft could carry the Space Shuttle's large cargo container. The 2 SCM C-5CS were assigned to Travis AFB, California. Based on a study showing 80% of the C-5 airframe service life remaining, Air Mobility Command began an aggressive program to modernize the C-5s in 1998. The C-5 avionics modernization program included upgrading the avionics to improve communications, as well as upgrading the navigation, surveillance and air traffic management systems to maintain compliance with national and international airspace requirements. It also added new safety equipment and installed a new autopilot system. Another part of the C-5 modernization plan was a comprehensive reliability enhancement and re-engineering program. The last of the Air Force's 52 C-5s are scheduled to complete the REP modification in fiscal year 2018. The rest of the C-5 fleet entered retirement by September 2017. The C-5 aircraft engines were upgraded from 4 General Electric TF-39 engines to General Electric CF6-80 C2L1F, F138 commercial engines. This engine delivers a 22% increase in thrust, a 30% shorter takeoff roll, a 58% faster climb rate, and will allow significantly more cargo to be carried over longer distances. With its new engines and other system upgrades, the REP-modified C-5A BCS became C-5M Super Galaxies. This modernization program also made the C-5 fleet quieter, Federal Aviation Administration Stage 4 compliant, enhanced aircraft reliability, maintainability, maintained structural and system integrity, reduced cost of ownership, and increased operational capability, well into the 21st century. Looking to the future, modernization efforts include incorporating advanced weather radar, mission computing, communication systems and air traffic management to meet FAA mandates and survivability in theater. The C-5 Galaxy's development was complicated, including significant cost overruns, and Lockheed suffered significant financial difficulties. Shortly after entering service, cracks in the wings of many aircraft were discovered, and the C-5 fleet was restricted in capability until corrective work was completed. The C-5M Super Galaxy is an upgraded version with new engines and modernized avionics, designed to extend its service life beyond 2040. The USAF has operated the C-5 since 1969. In that time, the airlifter supported U.S. military operations in all major conflicts including Vietnam, Iraq, Yugoslavia, and Afghanistan, as well as Allied support, such as Israel during the Yom Kippur War, and operations in the Gulf War. The Galaxy has also distributed humanitarian aid, provided disaster relief, and supported the U.S. space program. Aircraft weight was a serious issue during design and development. At the time of the first flight, the weight was below the guaranteed weight, but by the time of the delivery of the 9th aircraft, had exceeded guarantees. In July 1969, during a fuselage upbending test, the wing failed at 128% of limit load, which is below the requirement that it sustain 150% of limit load. Changes were made to the wing, but during a test in July 1970, it failed at 125% of limit load. A passive load reduction system, involving upward ailerons, was incorporated, but the maximum allowable payload was reduced from 220,000 to 190,000. At the time, a 90% probability was predicted that no more than 10% of the fleet of 79 airframes would reach their fatigue life of 19,000 hours without cracking of the wing.